Okay, so we're just going to have a look at the prior knowledge check for Chapter 7 on the stats, which is going on about hypothesis testing. But before that, we just need to have a bit of a reminder about the binomial distribution. Just in terms of how we use our calculator, make sure we're on par with that before we start. So binomial distribution usually gives me two numbers, 20, which is the number of trials, and 0.4, which is the probability that each of those trials has of success. So the first question, we are looking at the probability that x equals 5. So in those 20 trials that we're doing, what's the probability that 5 of those would be successful? So we're going to grab your calculators here. Now you're going to go into the menu, and then we are going to click on button number 7, which is the distribution button. Now for this one, because we've got x equals, we do have a couple of binomial ones here that we can have a look at. If I try and get the camera on the screen there. So we've either got the binomial PD or binomial CD. We are going to be looking at binomial PD, the probability distribution, because we've just got that equal. So we're going to click on number 4. And then from there, either ask us, do we want to do a list or a variable? A list would mean that we can have multiple answers all at once. And a variable means we're just going to get one at a time. Now, because part B is asking me for x equals 10, actually I may as well just do a list for this. So I've got x, which we're going to plug in the values of 5 and 10. We press equals again, and it takes me to the screen where I now get to put in the values of n and p. So n is now 20, p is 0.4, and now when I get that, it gives me my two values on there in my table as that list. So I know that this is equal to 0.0746, and this is equal to 0.1171. We're now going to go back to C. Now, because C, we've now got this less than or equal to sign here. That means I need to go to the cumulative distribution. So again, I'm going into menu number 7, but not binomial PD. We're going to have to scroll down here and go to binomial CD, which is on the next screen down, selection 1. I'm just going to do this one as a variable, just a one-off. So we've got x now. Well, x is now going to be 2. N is still 20, and P is still 0.4 from the time before. And it tells me this number here, if it gives it to you in standard form, just convert it, 0.0036. Okay. Now, for part D, this is a greater than or equal to sign. Now we do have to be careful here, because the cumulative distribution on the calculator is only going to give me a less than or equal to value for the probability. So what we're going to need to do is find a less than or equal to probability that I could use in conjunction with this. Now, because it's a discrete distribution, as in that we can only usually get whole number answers, what we're going to think about is, well, if they want 18 and above, what aren't they having in that? So what aren't they having in that is anything that is going to be 17 or below. So if we're not having the 17 or belows, how do I get left with 18 and above? Well, I'm going to subtract that from 1. So the first thing I need to do here is go back to my binomial CD, and now instead of the 18 I need to put the 17 in for my x. N and P is still the same, and that gives me 0.9999949587, and we're going to subtract that from 1. And if you can remember the little trick I told you how to subtract from 1, you essentially see what number needs to add to all these digits to make 9, apart from the last one you're going to choose to make up to 10. So for me, if I just choose to do maybe 6 decimal places, so 0, 0, 0, 0, 0, and if we round up to a 5, it will then be a 5. Like that. That's question 1. For question 2, We're then given a scenario. A fair dice is rolled 8 times, and x is going to be the number of 5s that we roll. So the first question is, well, what sort of distribution could we use to approximate this? This is a binomial, and if we think about what makes up a binomial distribution, it has to have a fixed number of trials. So we know that it's going to be 8. It either needs to be success or failure, so we only want 2 outcomes. Now in this case we have got that, because we've either got the outcome is a 5 or it isn't. Okay, so we've only got 2 outcomes for this particular situation. I know a dice usually has 6, but we're only interested in the number of 5, so we're only really saying it's a 5 or it's not, 2 outcomes. We need to have a fixed probability of success. Well, okay, on a fair dice, yes, that probability of success isn't going to change. The probability of rolling a 5 is going to be the same every single time. And lastly, each event needs to be independent of the last. So each roll of the dice needs to be independent. And yes, we can say that with fair certainty. So we can now say, well, this is going to be a binomial distribution. And we can approximate x with a binomial distribution with n now being 8. And the probability of success, well, the number of 5s, what's the probability of getting a 5 on a dice is 1/6. So this now becomes just the same as the questions above. So for this one, I need binomial PD. So into my menu, onto the distribution button, and then binomial PD, just as a variable. X is now going to be 2, n is now changed to 8, and p. Now what we can do for the probabilities, if it's not just a simple decimal, it's going to be recurring, but I want an exact answer, I can just type in a little sum here. 1 divided by 6, it gives me the 6 there. And that tells me the probability is 0.2605, rounding it. And for this one, similar sort of thing to what we had for D here. I need to make this 1 minus the probability that x is less than or equal to, so I always have to have one of those if I'm going to use my calculator. This wants 4 or above, so what isn't that? Well, that isn't 3 and below. So again, I need to switch now to binomial CD, just the variable I need, and now we're going to go 3, n is still 8, p is still a 6th. Now that tells me it's 0.969343, etc. But I'm going to subtract that from 1, so 0.0307. Let's cap it off there at 4 decimal places. Okay.